In the past few years, artificial intelligence has made leaps so rapid they've begun to feel almost surreal. We've seen models generate photorealistic images, compose symphonies, write novels, and even debug code. But behind the scenes, one of the most profound shifts in AI isn't just about what models can do, it's about how they learn. And at the heart of this transformation lies a quiet revolution, the rise of self-supervised learning. For decades, the dominant paradigm in machine learning was supervised learning. Train a model to recognize cats, you show it tens of thousands of labeled images, cat, dog, car, and so on. This works well, but it comes at a steep cost. Labeling data is expensive, time-consuming, and often requires expert human intervention. What if we could teach machines to learn from raw, unlabeled data, data that's everywhere, from the internet to sensor streams, without needing someone to manually tag every single example? That's the promise of self-supervised learning. Instead of waiting for labels, the model generates its own labels by solving cleverly designed puzzles based on the data itself. Think of it like teaching a child to understand language not by handing them a dictionary, but by letting them predict the next word in a sentence, or reconstruct a sentence after parts are missing. The model learns the underlying structure of the data by solving these internal challenges. One of the most powerful examples of this approach is the masked language modeling technique used in models like BERT. Here is how it works. Take a sentence like "the cat sat on the mat." Randomly mask some words, say cat and mat, and ask the model to predict them based on the surrounding context. The model doesn't know the correct answers ahead of time. It learns by trying to reconstruct the original sentence using only the context. Over time, it builds a deep understanding of grammar, semantics, and even world knowledge. But this isn't just about language. The same principle applies to vision. In models like SimCLR or MoCo, researchers use image augmentation to create multiple versions of the same image: cropped, rotated, blurred, color shifted. Then the model is trained to recognize that two different views of the same image are semantically equivalent, even if they look different. It learns to distinguish meaningful features, like edges, textures, and object shapes, from random noise. This is how a model can learn visual concepts without ever seeing a single label. Now here's where it gets really interesting. Self-supervised learning doesn't just reduce the need for labeled data, it unlocks something deeper: generalization. Because the model learns broad, transferable representations, it can be fine-tuned on small labeled datasets for specific tasks with remarkable efficiency. A model trained on billions of web pages can be adapted to classify medical images, translate languages, or summarize documents with just a few hundred examples. This is why self-supervised models are the foundation of today's most powerful AI systems. They're not just smarter, they're more efficient, more scalable, and more adaptable. And as we push toward AI systems that can reason, plan, and understand complex environments, self-supervised learning provides the essential scaffolding. But it's not without challenges. The quality of the learned representations depends heavily on the design of the pretext task, the puzzle the model has to solve. If the task is too easy, the model learns trivial patterns. If it's too hard, it fails to converge. And while self-supervised learning reduces the need for labels, it demands massive amounts of data and computational power. Training a model like GPT-3 requires thousands of GPUs running for weeks. Still, the trade-off is worth it. The ability to learn from the vast, unstructured data that surrounds us, text, images, audio, video, represents a fundamental shift in how we build intelligent systems. We're no longer limited by the bottleneck of labeled data. We're building models that can learn from the world itself. So what does this mean for the future? It means AI won't just be trained on curated datasets. It will continuously learn from experience, adapting as the world changes. It means smaller teams and startups can now access models that once required billion-dollar labs. It means we're moving closer to artificial general intelligence, not because machines are suddenly thinking, but because they're learning how to learn. Self-supervised learning isn't just a technique.